we begin chapter 3 with another derivative rule. We've had the product rule and the quotient rule, and this one is the chain rule. The chain rule is for calculating derivatives of composite functions. So before you can calculate derivatives of composite functions, you have to make sure that you can recognize them when you see them. And my advice is just like my advice to parents of young children, read it out loud. And when you read it out loud, if you hear yourself saying the word of, and the next word is not just an x, then it's a composite function. If you hear yourself saying quantity raised to a power, then it's a composite function. And if you have an exponent that is a function and not just a plain old x, then it's a composite function. Here's some examples. To read this out loud to you, I would say f of x equals sine of x squared. And when I said of, the next word was x squared, not just a plain old x. So that's a composite function. F of x equals the cube root of e to the x. Said of, the next word was e to the x, not just x. F of x equals the quantity of x squared minus 9x plus 4 raised to the third power. That is a composite function. And finally, f of x equals e to the 3x. I didn't just say x for my exponent, I said 3x, so it's a composite function. So this is the chain rule formula. And the chain rule formula, there's kind of a mnemonic for remembering it. I think that the g function looks a little bit pregnant. You see how it has that big pregnant parenthesis belly? And inside of its parenthesis belly is the little tiny cute little baby function h. So g is the mom, h is the baby. And here's the way to remember it. You differentiate the mother and you leave the baby inside. And then you multiply by the derivative of the baby. So it goes like this. So f prime of x, take the derivative of the mom, leave the baby inside, and then take the derivative of the baby. We'll do an example. Don't have to think about pregnant women the whole time. Right, looking at, see how natural log in that example, or the first one here, natural log is pregnant. Natural log is the mom. The baby is 5x squared minus 9x. So if I'm doing the derivative, do the derivative of natural log, which is 1 over x. But I'm not going to write 1 over x because I'm going to leave the baby alone. So I'm going to write 1 over 5x squared minus 9x. And then multiply that by the derivative of the baby, which is 10x minus 9. All right, take a minute and try the second one. The second one has a little bit of a trick. It's sort of like having twins. I'm doing the second one. I take the derivative of secant, and the derivative of secant is secant tangent. And I leave the baby alone in both places. And then I multiply times the derivative of the baby. All right, try these two, and then come back and start the video after you've given them an attempt. So when I did this one, I got f prime of x is equal to, and I sometimes like to rewrite things so that it looks more like the power rule. Whenever I see a square root, I think, oh, that's going to be a 1/2 power. 1/2, leave the baby alone, times the derivative of the baby. Now, I haven't done any simplifying as I was going through these problems. Just a reminder that if you needed to find the zeros of the derivative, you would want to rewrite this so it looks like cosine of x over 2 times the square root of sine of x. And so you could say, oh, well, I know that this is going to be 0 whenever cosine is equal to 0. So, for example, at pi over 2, 3 pi over 2, etc. Okay. G, I don't know if you noticed as you were doing G, but overall what G is a product of two functions. But then within that product, there's going to be a chain because it's not just e to the x. So we're doing both product rule and chain rule. People often ask me, how do I start? Which one goes first? And the way you start is by looking at your function overall and saying, well, overall, I see a product. So that's how I'm going to start. So I take the derivative of the first thing times the second thing left alone plus the first thing left alone times the derivative of the second thing, but now I'm going to do chain. So e to the x is the derivative, but I leave the baby alone, and then times the derivative of the baby. Sometimes it's helpful to use color as you're doing these problems, and I probably should have been using color all along. But if I see this as, I'm going to do f with color. So if I see f of x as the square root of sine of x, then I can say, well, first I'm going to take the derivative of square root. And I know that the derivative of square root is 1/2 and to the negative 1/2 power. And then I'm going to make sure to leave the baby alone and then multiply by the derivative of the baby. Some tips if you're having trouble deciding. The other thing is that people sometimes ask, well, who's the mom and who's the baby? One way to tell is you look at order of operations. What would you do first if you suddenly knew what x is? What I would do first is I would do sine of x. And what I would do second is the square root of x. So as we're doing derivatives, we work from the outside in. We're going to work with what we do last first, and then work our way down to what we do first. So kind of backwards order of operations, if that makes sense. All right, a couple more examples. This is a table example. So h of x equals f of g of x. So if I want to find h prime of 3, I'm going to do derivative of the mom, leave the baby alone, times the derivative of the baby. Now, order of operations, I need to figure out what g of 3 is first. I need to work my way inside out for these parentheses. So g of 3 is 0, so I'm finding f prime of 0 times g prime of 3. Notice that these are different numbers. We're evaluating our derivatives at different places because we had to figure out what g of 3 was before we could find the derivative of f. So now f prime of 0 is negative 5, and g prime of 3 is negative 6. So this one would be 30. Try the second one. Start the video back up after you've tried it. So we would do k prime of 0 is going to be derivative of the mom, the baby left alone, times the derivative of the baby. Okay, so g prime of f of 0 would be 3 times f prime of 0. Oh, it's the same as the last one, isn't it? So it's negative 6 times negative 5. All right. The last example is kind of a big problem. We have the square root of e to the 7x squared minus 9. And the big thing about this is babies having babies. This is the big mama is the square root function. Its baby is e to the, and its baby is 7x squared minus 9. So we're going to work our way backwards order of operations. If I knew what x was, the first thing I would do would be do 7x squared minus 9, and then I would raise that e to that power, and then I would take the square root. So I'm going to go back. So f prime would be 1/2 raised to the negative 1/2 power, because that's the derivative of square root. I'm going to leave the baby alone and give myself enough room. Okay, now I'm going to take the derivative of this function. So that would be to the, with the baby left alone, right? So that'd be e to the 7x squared minus 9. And then I'm going to multiply times the derivative of the baby. So it would be times 14x. If I rewrote this a little bit and tidied up, I would see that I have 14x times e to the 7x squared minus 9 over 2 times the square root of e to the 7x squared minus 9. And this 14 and the 2 can cancel. So there's a derivative function. That is the chain rule. Good luck.